This is the first lesson of 9 honors. The title is Laws of Exponents. Now I know, because I tutor middle school, that you probably already know the material in this lesson, but it's a good refresher. All right. First, there's a lot of facts that you need to know. Okay, for instance, these are just facts, exponent facts. You need to know x to the 0, for instance, is 1, except for 0 to the 0, okay? Then you need to know, let's say you have x squared divided by x squared. Well, that's just 1, right? Unless x is 0, of course. But you can see that if you subtract the exponents, you get 2 minus 2, x to the 0, which is 1, right? Remember that? One that's extremely important is if you have a negative exponent, it becomes positive when you get its reciprocal. So it works both ways. Now I move it up to the top and it's positive. So you need to know that. You need to know if you have, say, x over y to the negative 1, just flip it. And it becomes x over y to the positive 1. You need to know that if you have x cubed, y cubed, that's the same thing as xy cubed. It's not the distributive property, people. It's just laws of exponents. If you have x squared over y squared, that's the same as x over y squared. Okay, so those are some basic facts. Just to remind you, there's something called product of powers. That's when you have a product of powers, okay, such as x squared times x to the third, okay, you multiply the coefficients. We'll talk about what a coefficient is in a second in case you forgot. And add the powers for your like bases. Okay, so x squared is the same as 1x squared. X cubed is the same as 1x cubed. These are called coefficients, the ones. So you multiply them, 1 times 1 is 1. And then you add the exponents, 2 plus 3, you get 1x to the 5th. But of course you don't need the 1. All right, so we add the exponents. I'm sure you remember that. Okay, division of powers. Cancel out common factors for the coefficients. Then I'm going to have you make all the powers positive. There are different ways to do these problems. Okay, I'm going to stick with one way. Make all powers positive. In other words, if you have a negative power in the numerator, put it in the denominator. If you have a negative power in the denominator, put it in the numerator. Then I'm going to have you subtract the powers for like bases. But there's more to it. Okay, you're going to do larger minus smaller. And leave the base with the power where the higher power was. Okay, what do I mean by this? So let's say you have 8x to the negative 2 y over 4 xy to the negative 3. number 1, you can cancel out the 8 and the 4, making the 8 a 2. Then you're going to take your negative powers, you're going to move their locations. Oh, look at that. You just end up adding here. You don't even end up dividing. All right, let me go to the next page and give you an example where you're going to have to subtract. Okay, so let's say we have 16 m to the negative 2 k squared over 8 m to the negative 4 k. So first cancel out the 16 and the 8, the coefficients, make that a 2. I want you to physically move the negative exponents. Hold on, that looks too messy to me. I know. Okay, so now you're going to subtract the exponents. You're going to do 4 minus 2, and then you're going to do 2 minus 1. And that would be your answer. Okay, we're going to do more examples. Okay, then we have power of a power. To do power of a power, you're going to raise the coefficient to the power. Keep in mind being careful of the signs. So you have to look for whether this coefficient is positive or negative. Because if you're raising a positive or a negative to an even power, it doesn't matter because you're going to get a positive. But when you have a negative and you raise a negative to an odd power, it's negative. So keep that in mind. Negative to odd is negative. Okay, so you're going to raise the coefficient to the power. Then you're going, for each variable base, you're going to multiply the powers. Okay, so let's look at this example. Negative x squared y. I'll put a 2 here. I'll make it nicer. Negative 2x squared y. Okay, let's say we're raising that to the third power. So it's going to be negative 2 to the third, x to the 2 times 3, y to the 1 times 3. That's going to be negative 8, x to the 6th, y to the 3rd. That's how I want you guys to do it. All right, so let's take a look at some examples. Example 1, I have 4mn times 3n squared over the square of negative 2m squared n squared. Okay, so you can start it however you want. Okay, in the numerator, I'm going to get 12m n to the 3rd, multiplied the coefficients, and then I'm doing product of powers in the numerator. In the denominator, power of a power, I get negative 2 squared m to the 2 times 2, n to the 2 times 2. Now I have 12m n cubed over 4m to the 4th, n to the 4th. When I subtract, I'm going to do larger minus smaller. First, I'm going to cancel out these coefficients. So for the m's, I have the larger power in the denominator, so I'm going to do 4 minus 1. For the n's, I have the larger one in the denominator, so I'm going to do 4 minus 3. And that would be my answer. All right, let's take a look at number 2. Okay, so I have 18k over 6k to the negative 2j to the negative 3. Number 1, cancel these out. Number 2, move the negatives so that they're positives. Now just use product of powers here. Okay, number 3. So for this problem, I'm going to have all of this to the negative 2. So number 1, I'm going to flip this. That's one of the properties I showed you in the beginning. And make this a 2. Now I'm going to clean up the inside first. Different people have different styles here. So for the J's, I'm going to subtract the larger coefficient, which is in the denominator. Now I'm going to square everything. So I'm going to get 4 squared k to the 6th, 3 squared j to the 6th. And there you have it. All right, let's take a look at number 4. So for number 4, I have 5x to the negative 4, y to the negative 5, over 15x to the negative 7, z to the 4th, all to the 3rd. All right, number 1, I'm going to clean up the inside, cancel those. I'm going to move my negatives. So when I move my negatives, I have x to the 7 up here, x to the 4 down here. The z is fine, it's positive. But the y has to go down. Okay, so now I'm going to subtract the 7 and the 4. So when I subtract that, 7 is larger, so that goes in the numerator. I like to write these in alphabetical order, so I'm going to write y to the 5th, z to the 4th. Now I'm going to cube everything. So I get x cubed cubed, 3 times 3. 3 cubed, 27. 5 times 3. 4 times 3. Okay, and that would be your answer. So we get x to the 9 over 27, y to the 15th, z to the 12th. Let's take a look at number 5. Hold on. I don't like the way that squared looks. Looks too large. I like to make it look higher. Handwriting matters in math. Okay, some people will tell you it doesn't, but it interferes with success. So, got to be cognitive of that. All right, so when I'm looking at this question, number 1, I'm going to cancel that out because that's just 1. But I'm going to flip this entire thing and make it a positive 3. So I have 3 squared x, 2 squared y to the 3rd over 6 to the 4th x cubed times 3, all to the 3rd. Just, you have to pick something and stick with it. It's important to do that. All right, well, this here, earlier on I had told you that that is the same thing as just 3 times 2 squared, or 6 squared. So I'm going to use that fact. All right, the reason I'm doing that is because then I can cancel these and have 6 squared in the denominator, which I like better. When I subtract, I'm going to do 3 minus 1. That looks like a 0 now since there's nothing there. So I have 3 minus 1, so I get 2, so I get x squared. And then I just have this y cubed in the numerator. All of this to the 3rd. So now I have y to the 3 times 3. I have 6 squared to the 3rd, which is 6 to the 6th, 3 to the 3rd, x to the 6th. So my final answer is y to the 9th over 1,259,712 x to the 6th. You are allowed to use a calculator to compute this if you wish, right? Okay, so the next thing that I think is fun is I want you to be able to write things as a single power. Okay, write as a single power of 2. Okay, so let's say we have the following question. 2 times 8 cubed. what I'm going to do is I'm going to write the 8 as 2 cubed. Then on the inside here, I get 2 to the 4th, and 2 to the 4th to the 3rd is going to be 2 to the 12th. That's it. So here in the second problem, I'm going to have the cube of 4/64. So I'm going to write this as 2 squared. I'm going to write this as 2 to the 6th, all to the 3rd. I'm going to subtract these, larger minus smaller, and then I'm going to multiply. That's it. Okay? All right, 1/16 times 2 to the 3rd. So I'm going to write that as 1/2 to the 4th. Cancel these, subtracting, and you just get 1/2. 2 to the 3rd times 4 to the 3rd. 2 to the 3rd, well, 4 is 2 squared. So that's 2 squared to the 3rd. Well, isn't that 2 to the 6th? So then I just get 2 to the 9th. Add the 3 and the 6. Okay. One more question on this. I'm trying to keep the first lesson short. Write the expression simplified without a denominator. Okay, here we go. 5x cubed y all to the 3rd over the opposite of xy squared. Well, all this to the 3rd is 125, x to the 9th, y to the 3rd. In the denominator, you're squaring a negative, so that just becomes positive. X squared, y squared. And then when I subtract, I have 9 minus 2 and 3 minus 2. And there you go. All right, that completes the first lesson. I will be doing this in class as well, but you will also be required to watch it for homework and make sure you have copious notes. Thank you, guys.